Superstars of CircuitPython. Let's cover some of the most common installation and board issues that trip up new CircuitPython students and show you some solutions. I'm Professor John Gallagher, and I've taught hundreds of students in person in my physical computing courses, and I reach many more online via YouTube. In this lesson, I'll cover some of the most common issues that I've seen trip up new students. I hope the solutions are clear and that this helps you as well. First thing is to check to make sure that your board is plugged in with your USB cable, both to the board and to the computer. Now, most boards have some sort of indicator light to show that the board is powered on. It's usually a tiny light located near the USB port. The one for the Circuit Playground Bluefruit is right here. It'll be a steady green when the board is ready for CircuitPython programs. The one in the Raspberry Pi Pico W is right here, and it intermittently flashes green when the board is set up properly. Now, the Pico boards are a bit tricky. This light will flash if CircuitPython has been set up, but if you're working with a new board that doesn't have CircuitPython installed, then you're not going to see any lights flash. Remember, there's almost certainly some online documentation that can tell you more about your board if you're wondering where the indicator lights are and what they should be showing. Another very common problem is when folks use the wrong type of USB cable. Some USB cables are charge only and they won't work. Data cables allow data to be sent between your board and your computer, and that's what we need. Now, all of my students have been given data USB cables, and we put a little piece of tape around the ends of the cable to indicate that they're ready to work with the board. Otherwise, there's no way to tell that a cable is a data cable just by looking at it. Now, if you have a charge-only cable, then when you plug your board in, you might see lights, but you won't see your board mount on your computer, even if you press the reset button. If you're not sure you have a cable problem, you can try out the cable with different boards, or you can find a friend who has a working cable to make sure that your board can connect with their good cable. Now, when you're writing your own CircuitPython programs, you want to make sure that your board is running CircuitPython. And you'll know this because when you plug your board in, it will say CircuitPy. You should also be able to find the CircuitPy volume when your board is plugged in, and when you double tap on a tab in Mu, this will bring up the Save As dialog box, and you should be able to find CircuitPy and save your files here. Also remember that the CircuitPy volume is where your LIB folder is. That's where all the files are that extend CircuitPython's capabilities. For example, you're going to add files to your LIB folder on your board when you're ready to work with sensors, motors, LED lights, and other devices. And there are also going to be times when you want to add additional files to work with your programs. For example, you might want to add sound files or configuration files to work with Wi-Fi. These should all be saved to your CircuitPy volume as well. Now, you should not have any files that end in UF2 in your CircuitPy volume. If you see any of those in there, drag them into the trash. The UF2 files are used when your board is in bootloader mode. That's where you can install or upgrade CircuitPython. Now, if your board is plugged into your computer and you see it with a name ending in boot, then that's bootloader mode. The Raspberry Pi Pico boards, the Arduino RP2040 boards, or any other boards that have the RP2040 chip in them, they won't end in boot, so they're the exception. Their bootloader mode just says RPI-RP2, but the giveaway that a board is in bootloader mode is that it does not say CircuitPy. Remember, we're only in bootloader mode when we first install CircuitPython or we upgrade CircuitPython. Either of those are what we're doing when we drag over the UF2 file. All other times, the board should say CircuitPy. Bootloader mode is not for your Python programs. Nothing in there should be named .py. If you have any .py files in bootloader mode, just drag them into the trash. They're just taking up space. Another thing to remember, when adding or upgrading CircuitPython to a board, make sure that you've got the right UF2 file. Our installation lessons show that you can find all of the setup files at circuitpython.org under the Downloads tab, but be careful. Some of these boards have very similar names. For example, there's a Circuit Playground Express and a Circuit Playground Bluefruit. There's also a Raspberry Pi Pico and a Raspberry Pi Pico W, which my students use. These are all different boards, so you want to make sure that you've downloaded the right UF2 file for your board, otherwise your installation or your upgrade won't work. Now, the library files that you find in the Libraries tab at circuitpython.org do work with any board, but you want to make sure that you're using the library file for the right version of CircuitPython that you're using. For example, if you've just upgraded a board to CircuitPython version 8, then you want to make sure that you download and use these upgraded version 8 libraries. If you forget how to do this, the setup lesson in the playlist can walk you through the steps. Now, if your board is in bootloader mode, but you've properly configured CircuitPython, you should be able to just unplug your board, plug it back in, and see CircuitPy. Circuit Playground boards also have a reset button. A single tap, not a double tap, should restart the board, and you should see CircuitPy. Now, most boards do have some sort of reset button, but Pico boards don't have a reset button. That boot cell button is not a reset button, but you can just unplug the board, plug it back in, and that should remount the board as CircuitPy. If not, then you may need to drag over the proper CircuitPython UF2 file to your board when in bootloader mode so that you can make sure that you've got CircuitPython set up. If you need help on how you can configure your board, you can see the setup video in our playlist, or you can search online for your board's Adafruit Learn Guide. Now, another thing to remember, if your board becomes disconnected and you reconnect it, Mu might forget where the board is. To fix this, just double-click on that Files tab in Mu. This brings up the Save As dialog box. Find the CircuitPy volume and save over the code.py file that's in there. Now, I find that sometimes Mu is a bit quirky and the program doesn't run right away when you save as like this, but if you tap the Save button after you've saved this, and always make sure you've clicked the Serial button to open the Serial console, you should see more text show up in the Serial console and a message showing that your code is run or that you've got an error. Remember, if you do have errors, there should be a message giving you more info in the Serial console. Sometimes you have to scroll up to read it all. Also remember that you can increase or decrease the font size using the Zoom In or Zoom Out buttons, and on the Mac there's a keyboard shortcut. Shift-Command+ increases, Command- decreases. On Windows, it's Control+ or minus. Clicking the check button in Mu also provides some additional information for diagnosing code problems. Now, my students and I have also noticed that sometimes the Serial console doesn't show any activity, even if you try to open up the Serial console and resave your code. If this happens, you're seeing a blank Serial console, then you can try to open the Serial console, type Control-C to break any executing code and enter the REPL mode, then Control-D to get out of the REPL mode, press Save again to rerun your code, and this usually works. If not, you can try quitting Mu, unplugging your board and then plugging it back in, and then restarting Mu. In extreme cases, you might even try rebooting your computer. Now also know that most boards that Adafruit sells also have a Learn Guide online, and this can provide some great additional documentation. Just search online for Adafruit, the board's name, and Learn Guide. Here's the Learn Guide for the Circuit Playground Bluefruit. The guided tour page provides all sorts of useful information, including the location of the green LED lights that indicate that the board is getting power, and the red light that pulses when the board is in bootloader mode. Another thing to do is to search for the troubleshooting pages for the latest advice. Try searching for CircuitPython, your board's name, and troubleshooting. There's a generic CircuitPython troubleshooting page that has great advice, and sometimes just the board name and troubleshooting provides generic advice, especially if your board wasn't manufactured by Adafruit. Be careful with some advice, though. Some pages refer to MicroPython, which is a different variant of Python than the easier-to-use CircuitPython that we're using in our course. If you're using CircuitPython, skip the MicroPython advice. Here's a troubleshooting page for the Circuit Playground Bluefruit. If you scroll down, there's all sorts of advice. For example, this section talks about virus software and other utilities that cause problems for Windows users. And down here is some important information about the status lights. If your CPB flashes all the lights once in green every 5 seconds, then the code is done running and it ran without errors. That would happen if the code didn't have an infinite loop like a while true loop. Flashing red twice means your code has an error in it. Look to the Serial console and click the check button for more insight. And 3 yellow flashes means your board is in safe mode. Safe mode is a way to start your board without executing a program. This is sometimes useful if your code is behaving weirdly and you want to modify code before running it again. Maybe your code makes your motor run constantly or a sound play constantly. That's incorrect and you don't want that to happen while you're coding. Well, you can enter safe mode on a Circuit Playground by tapping the center reset button once, then within a second, tapping it again. If you tap it too quickly, you'll get into bootloader mode. You want to make sure that you have a pause in between the first and second tap. You have to be in CircuitPy mode to be in safe mode. If you do this successfully, you'll see the lights flash yellow 3 times, and you can check the Serial console for more info on safe mode. Also know that the CPB NeoPixels all turn white when you're in the REPL, and when you press Control-D to get out of the REPL, the white lights turn off. Further down, there's also information on what to do if you run out of space on your board. The first thing is you should delete anything that you don't need on the board. For example, my students oftentimes perform exercises with sound files. Those sound files are big, and if you're currently running a program that doesn't need those sound files, then you should delete the sound files from the board. Mac users also have a problem with hidden files lingering on the CPB. Those take up space and you can't even see them. Now on the Mac, if you press Shift-Command-, that'll toggle showing or hiding files. Hidden files are in gray. You can try deleting any hidden files on the CPB. Sometimes you have to open hidden folders and then delete what's inside. And if that doesn't work, there's another fix. You can use the REPL to erase all the files on your board. Now before you do this, make sure that you back up any files on your CPB that you haven't saved, like code.py, maybe your lib folder, or any sound files that you want to save to run on the board with this program. I copied over boot_out.txt. You actually don't need to make a backup copy of that because that's recreated every time you start your CircuitPython board. Next, open Mu, click the Serial button, and press any key to enter the REPL. Then at the triple greater than prompt, enter import storage, then storage.erase_filesystem, one word, open and close parens, and then when you press return, all files will be wiped off of your CircuitPy volume. You'll probably get a message that your device was detached. That's normal because you just wiped out all the files. Now, when you do this, you still have your previous version of CircuitPython on the board, so you shouldn't need to go into bootloader mode, you shouldn't need to do anything with UF2 files, you should see your device reappear on your computer as CircuitPy. And if you look in CircuitPy, it might look like nothing was done, but what you see here was created automatically as part of the restart process. If you try to expand the LIB folder, you'll see there's nothing in there, so we need to replace it with the stuff that we copied to the desktop. Now, there is a code.py file on here, but if you open it up, you'll see that it just prints hello world. That's also not what we had here before. Now, if you're a Mac user, you might see that there are still some invisible files on your computer. Those are these gray ones up here. Remember, Shift-Command-Period will show or hide your invisible files. That's normal. These first ones that are created don't take up much room, and they're always recreated by your Mac. They might fill up over time depending on what you do with your CPB, but you can certainly leave these in here for now. So I'm going to copy over my lib folder. I'll speed up the video so you don't have to wait. If I click on the expansion triangle, I can see all of my previous library files are in there. Nice. And I'll copy code.py back over to my CircuitPy volume. I'm going to replace the one that was there. I don't want that hello world code. And I'm going to throw out boot_out.txt. That's already on CircuitPy. It's created by the board, so I don't need that. And you can keep the backup of these other files on your computer. I've already saved them elsewhere, so I'm going to delete them from my desktop too. If you scroll down further on the troubleshooting page, you'll also see that Adafruit has some programs that you can download that will also help erase your board. Here's the button to download the code for the CPB. Now, you shouldn't need this if you've just erased things using the REPL, but if you want to try this out, you've got this as an option. After you download the file you need, just follow these steps. Now, for those using the Raspberry Pi Pico W board, or any other boards that use the RP2040 chip like the Arduino Nano RP2040, the Adafruit Installing CircuitPython page for the Raspberry Pi Pico has some additional advice. So you can search for this page, find this section on the left-hand side that says Installing CircuitPython, and then scroll down here, and it says if your Pico ever gets in a really weird state and doesn't even show up as a disk drive when installing CircuitPython, try installing the nuke UF2 file, which will do a deep clean. It'll also wipe out any files that are on this board, but it can be an extreme way to try to fix things if nothing else will work. Again, for my students, nuke.uf2 does not work on the CPB, but if your Pico W board gets flaky and any other fixes work, try this. Download the nuke UF2 file, enter bootloader mode by holding down the boot cell button on your board and plugging your board back in. Then the board should mount with the name RPI-RP2, then drag nuke.uf2 onto your board. That should totally wipe out all files on your board, so you're going to have to do a complete reinstall. I've saved all the files I need on this folder here called Pico W File Backup. But if you don't have the file saved to your desktop, you can follow the instructions from our install lessons. So first, while in RPI-RP2 mode, drag over the UF2 CircuitPython install file. That'll put CircuitPython on the board. When it's done, it'll dismount RPI-RP2 and remount to CircuitPy. Then I'll drag over all the other files that I need. For me, that's my LIB folder, the settings and secrets file, and my code.py file. And now I've got a freshly cleaned Pico W board. It's a bummer if you've got to redo all this, but sometimes you run into problems with the RP2040 boards, and this is usually the fix you need. And if you're still struggling, there are a couple of ways you can get advice from others. Adafruit runs a Discord server. You can access it from any browser by entering adafru, adafru.it/discord. You might be asked to create a Discord account if you don't have one, and approve the invite from Adafruit. Discord also has apps available for Mac OS and Windows if you'd rather use those. Now be sure to read the welcome message on the Adafruit server. There are important tips here. For example, you should surround any code that you paste in using tick marks. Those are the accent marks that are above the tab key on the US keyboard. It's on the same key as the tilde character. Don't confuse this with a single quote or the apostrophe key. And if you enter multiple lines of code, surround the code with 3 tick marks. 3 tick marks before and 3 tick marks afterward. That'll just format the code so it's much more readable. Do that and you're more likely to get help. Now you can post your questions to any of the channels over on the left. Help with CircuitPython and help with projects are most likely to be useful for my students. Now you add your message in this little area down here. If you press return, your message is posted. If you shift return, you'll add new lines before posting your message. And if you click on this little plus button, you're also able to upload images. When you post a new message, feel free to start with, "Hi, I'm new here. I'm new to CircuitPython." Now after you post your notice, you can leave Discord open because I often find that people will respond within minutes. But also if you quit out of Discord and get back in, you can click the inbox tray in the upper right to see if anybody has responded. And if someone has been especially helpful to you, you can post an additional thank you down here in the Hug Reports channel. Finally, Adafruit runs a support forum that you can access through your browser at the address forums.adafruit.com. You have to create an Adafruit account to use this, but it's the same account that you would use if you ordered stuff through Adafruit. There are sections for all sorts of topics, including Adafruit I/O and Adafruit CircuitPython. The Discord and the Adafruit forums are really best-in-class customer support. I use these all the time to get help myself. There are just a ton of really great resources out there. You can sign up for newsletters at adafruitdaily.com. You should follow Adafruit, Raspberry Pi, Arduino, Instructables, and LearnGuide authors on social media. This is a great source for inspiration. So hopefully the tips in this video will help you overcome any problems you've run into when working with CircuitPython. Now continue to hack.